Here in section 2.8 we're going to continue with our shifting. Now we're adding a phase shift. Amplitude still the same. What we've done here, the way we want to write this, we have taken this value here. Again, this is our omega value for our Greek letters. And we want to write this so that we still have x all by itself, and so sometimes we're going to have to rewrite our equations. And distributive property is what we're using here. Here is another Greek letter, this is phi. And so when we write this, here is our phase shift. And again, if this is minus here, then we're going to go to the right, plus goes to the left. So we're going to go the opposite direction for that shift. Now when we bring this value out, that is going to tell us our frequency. That means we're talking about the number of times the graph repeats in whatever the period might be. If we're talking sine and cosine, that is 2 pi. So we're talking about number of times the graph repeats in 2 pi. All right, now our period, that is still going to be the length it takes to make one oscillation. Takes. All right, that's again paying attention to those critical points as we go through this, and then again B value at the end there, that's our vertical shift. So break this down into parts. All right, we're paying attention to our critical points as we go. First thing I'm going to want to do, remember I just said that we're going to have to write the x by itself. So I'm going to factor this 2 out of here. So when we rewrite this, we're going to have y is equal to 3 times the sine of, now here's where I'm going to use the brackets and 2. So I'm taking the 2 out of each of these. So now I have x minus pi over 2 when we rewrite that value. Okay, so now if I just think about, say y equals 3 times the sine of x. Let's look at that for our critical points. First of all, our graph, let's say that this is pi, 2 pi, 3 pi. Over on this side we're at negative pi. So if I'm going to graph y is equal to 3 times the sine of x, I know sine starts at 0 and amplitude is 3. If I'm going to just graph y equals 3 times the sine of x, then my critical points would go here at 2 pi. Now we're crossing again at pi, up here, down here. Those would be the critical points that we start with. Now, as we do these shifts, things that we want to pay attention to, first of all, the 2 right here changes our period. So now we're going to, again, think of 2 pi divided by 2 gives us a period of pi. So we can change that. So now we're going to still have a critical point there. Now we're going through to here, halfway we cross again, halfway in between those, high point, halfway in between those, low point. There's some more critical points. Now we also need to look at what just happens when we do this piece. We're going to, because we're subtracting pi over 2, going to move everything to the right pi over 2. Okay, so on my graph, there's pi over 2. So I'm going to scoot all the points over that far. So this point goes to there. This point, halfway in between. This point, halfway in between. This point, over to here. So we've just moved all of those critical points. So now we're coming up this way, curves back down to there, and that takes care of each of those shifts. Now we can continue this back. We're going to then have another minimum value there, goes through that point, max there, goes through here. So we can see how that graph continues with that shift. Another minimum value continues this way through here, and we could again go up and through this way as well. So as you find those critical points, start asymptote, period, just like we've been doing, then add that shift afterwards. Last thing you would do then at the very end is if there were a vertical shift, that would then be the next step. So if we were to add 1 to each of these, I could scoot every one of those critical points we just found in green up 1 unit.